Hello YouTube, welcome back to the channel. So in today's tutorial, we're going to go ahead and simply learn how to create a customer churn prediction system using machine learning. Specifically, we're going to be going ahead and using deep learning to predict customer churn instead of a data set. So we're just going to go ahead and create a notebook here. So I'm just going to go ahead and create an IPython notebook. So once I have this notebook created, I'm going to go ahead and simply let me just talk about the data set that we're going to be using before we jump right into it. So we're going to be using this telco customer churn data set. So this is a data set that shows customers, like we're going to predict customer churn, basically if a customer is going to leave or is going to stay within the last month. So that's basically the data that we have right here. So this data can be found, data set can be found on Kaggle. You just go to Kaggle and just simply type in telco customer churn and you'll be able to find this data set. If you guys are having any problem finding this data set, I'm going to leave a link in the description so that you guys can have access to it. So great. So I assume that you already have this data set already downloaded. So I do have it downloaded and it is in this folder called datasets, and I call it churn customer telco customer churn.csv. Okay. So once we have created our IPython notebook, I'm going to go ahead and give it a name. So I'm going to say telco let me say telco underscore customer underscore churn. Okay, just like that. So once I have that created, I can simply begin to go ahead and code. So I'm just going to make this a markdown cell and let's just give it call it telco customer churn, just like that. So I'm just going to go ahead and run that. So once we have this, let's go ahead and import the necessary libraries that we need. So I'm going to make this a markdown cell and I'm going to say import necessary libraries. So we're going to import the necessary libraries that we need to begin to work on this. So I'm going to import the necessary libraries. So the first thing I'm going to go ahead and do, I'm going to go ahead and import pandas. So I'm going to say import pandas as pd. I'm going to go ahead and import numpy as mp. I'm going to also go ahead and import cbon as sns. I'm also going to go ahead and say from matplotlib, right? From matplotlib import pyplot as plt, just like that, and I can run that cell. So once I have all those libraries imported, I'm going to go ahead and read the data frame into read the CSV file, which is just like this data set right here, which you have read. I'm going to read it into a pandas data frame. So I'm going to say pd.read underscore csv, and then I'm going to specify the partition data. I'm going to say dot/data sets / I call data set and I called it telco customer churn. Yes, I hope that's the name I gave it to it. So let me just get it right, .csv. So let me just check if that's the name I give it to. Okay, I used Pascal naming convention, so I need to make these terms to be uppercase. So uppercase, actually it's not Pascal naming convention, I mix those convention with this. Okay, so once I have this done, I'm just going to run it to load the data frame. Okay, we have an error there. I think it's about to no such file telco customer churn. Okay, let me just check the data, make sure I get the name right. So telco customer churn.csv. So let me just check that. So it's in datasets, and then telco customer churn.csv. So that's the name of the file. So this is customer, so I get the spelling of customer wrong, so I still get an error and it says about the file. So you can just get the name of that specific path right here. So let me just try to open this and I can just get the path right here. So I'm just going to copy that to make sure I haven't made any errors. So I'm just going to copy that and simply go in here and paste it right here. So I'm just going to delete all of this and paste it there. Yeah, that's basically it, and run this one more time. So once we have that done, I'm just going to say df.head to visualize that data. So we have the data set right here. So sorry for those errors of specifying the path to the file. So once I have that done, I can just go ahead and close this part. So once we have that done, I'm just going to go ahead and drop the unwanted columns. So I'm just going to make this a markdown, and then I'm going to say drop unwanted columns, because we have a lot of unwanted columns here. We can see we have the customer ID column. We don't really need the customer ID column, so I'm just going to go ahead and drop it. So I'm going to say df.drop drop. I'm going to say df.drop, not drop NA. So df.drop, and what do you want to drop? You want to draw the customer ID, which is this column right here. I'm going to drop the custom ID, and I'm going to say in place is going to be true, and axis is going to be the column axis, so columns, and then columns, and then I'm going to say in place is going to be true, and I can do a df.head just like that. So now you can see we don't have that column anymore, which was previously here. Now we don't have it, so instead of having you can actually check the shape if you want, but for now we just keep it this simple, and we'll move on from there. So now that we have that, let's go ahead and actually inspect the different data types that we have. So I'm going to say inspect data types right here, and then press enter. So I'm going to say df.d types, and then that's going to return to me the data types that I have. So we can see that most of the data type, like monthly charge, is a float, total charge to be a float or an integer as well, but now it's an object, which is not supposed to be true, which is not supposed to be the case. Yeah, so let's go ahead and actually encode the total charge, this column, to be a floating number. So I'm just going to go ahead and do that. So I'm just going to call it I'm going to make this a markdown cell, and I'm going to go ahead and say that data types fixing, just like that, and simply run it. So to fix the data types, I'm going to say df, and I'm going to get access to the total charges column, because I want to make that to be a type number, because right now it's a float, because charge is supposed to be numerical, and you can see here it's going to be a number and not an object type. Okay, so I'm going to say pd.to underscore numeric. So pd.numeric, and then in here I'm going to say df, and I'm going to specify which column I want to do, which is going to be the total charges. And then I'm going to go ahead and specify the errors. I'm going to say errors, and errors I'm going to say course, just like that. Once I have that, I can simply go ahead and run this. So once I have that run, we got an error right here. So let's see, okay, total charges and not charge, so total charges, and then yeah. So once we have that, I can simply do a df.d types just to check if the type has changed. So we have total charges and it's of type now float. Okay, good. So once we have that done, I'm going to go ahead and deal with check in the missing value. So I'm going to make this a markdown cell, and just say missing. It's going to be missing values. So to check that, to deal with the missing value, what I'm going to go ahead and do is I'm going to say df.isNA, and then I'm going to check the sum of all the missing values for each column. So you can see that total charges, we have 11 missing values because we have used course right here, right? So what you can simply go ahead and do is drop those missing values, because 11 of them is not a significant number. So I'm going to say df.drop NA, and then I'm going to say in place is going to be equals to true, just like that, and simply drop the missing values. So once I have them, I'm going to check if I have any more missing value, does it the sum, and then run that. You can see now I have no missing values. So great. So now that you have done that, I can just do a df.head just like this, and simply run this data set, run that code cell, and now we have our data set being as follows. So let's go ahead and do some explorative data analysis before we jump into label encoding, because we need to encode some of these categorical data sets, categorical columns rather. So therefore, let's do some explorative data analysis. Let's do some EDA, and then we jump into that. So if you guys are not familiar what EDA is, or EDA stands for explorative data analysis, and I have a lot of video explaining what EDA is. So I'm going to leave these videos in the description so you guys can check what EDA is and be able to analyze data. So I'm going to say gender population. This is going to be, sorry, I'm going to say EDA, just like that. And down here, I'm going to perform my first EDA. And this is going to be for the gender population. So I'm going to say gender population. Like how many, because we have gender, right, population, we have male and female, right? So I want to analyze like which percentage of our data is male, which one is female, and compare whether the males are more significantly than females. So I'm going to say gender, gender underscore df, and gender df is going to be df.group by right, and I'm going to group by the following. So I'm going to group by the gender. I'm going to go by the gender column, and then I'm going to get a count of it, so a count of it, and then I'm going to simply select the churn one, so the gender. Okay, so once we have that gender comparison, like how many people they have churn and how many people they haven't churn and stuff like that. So once I have that, I can just go ahead and I can visualize. I can say gender underscore df, and then see we have it right here. We have male and female. Okay, So and the name is the name of this series is just the churn series, because you have set the churn series right here. So I want to go ahead and plot a graph. So I'm going to use PLT, which is matplotlib. I'm going to create a figure, and I'm going to say fig size, and fig size is going to be equals to the following. So fig size is going to be 7. This will be 7 by 5, 7 by 5 image, and then I'm going to say gender underscore df dot plot. We're going to use pandas to plot this. We're going to plot h, just like that, and then blt dot title. I'm going to give it a title, and the title can be anything. So we're going to say gender population, just like that, population, and then I'm going to say plt dot show, just like that, and simply run the cell. So once I run it, I have this value right here. Okay, this is supposed to be 7 by 5 by 7, 7 by 5 rather, not 87. Yeah, so you can see that the gender comparison right there is very similar. Most gender they're basically almost the same value, right? So yeah, so but I think there are more females, there are more males than females in our data set, right? You can see males are more than females. Now let's look at the churn comparison, right? How many people they have churn and how many people they haven't churn, right? They have stayed. Okay, so I'm going to make this a markdown cell, and I'm going to simply make this to be churn rate comparison. So what I'm going to do here, I'm going to say churn underscore df, and I'm going to go ahead and say df dot group by, and I'm going to group by the following. So I'm going to group by churn, and I'm going to say dot count. I'm going to count that value, and I'm going to get the specific column. So I'm going to get the gender column, and I'm also going to get the senior citizen column. So I'm going to say senior citizen. So I just want to select 2 columns in this case, so you can feel free to select any column that you want, but I'm going to go with these 2 specific ones. So I'm going to say churn underscore df, and then let's try to visualize it to plot that out. So we have this graph here. So these are people who have churn. In this case, these are the gender for those specific people. So I'm just going to go ahead and simply plot this. I'm going to say plt dot figure, and I'm going to say the fig size, and the fig size is going to be equals to the following. So the fig size is going to be 7 by 5 as we did previously, and I'm also going to do plt dot pi. I'm going to do a pie chart to visualize this, and I'm going to say x is going to be equals to the gender, right, and then which is this column right here, and then the data is going to come from the churn underscore data frame, and then I'm going to say use auto pct, and this is going to be equals to the following. So I'm going to simply say a string here, and this has a bit of weird syntax. So percentage 1.2, and then f, and then percentage, right? So once I have that, I'm going to now specify the labels. So the labels is going to be the index of this data frame right here. So I'm going to say churn underscore df dot index, just like that, and I can simply pass in a title, plt dot title, and I can specify the title to be churn rate comparison. So churn rate comparison, just like that, and simply down here I can do plt dot show, and then just run that code. So now we have the graph here, so we can see the ones who have churn and the ones who didn't. So yeah, that's basically it. So we have to about 27% of the people have churn, and then the other percentages remain. So that's basically it. And now let's look at the different payment method, because if you look at our data set, we have the different payment methods right here. So let's look which is the most commonly used payment method, or let's just compare the payment method category. So to do this, I think the best thing to do here is to use a pie chart. Let's just go ahead and use a pie chart for this, and let's see how it's going to look like. So let's use a pie chart. And so to use the pie chart here, what I'm going to do, I'm going to create a markdown. So it's going to create a markdown here, and I'm going to simply call this we say payment method, just like this. So I'm going to say payment underscore method. So payment let me just call it payment method, just one word, payment method underscore data frame, and this is going to be equals the following. So I'm going to say df dot group by. So this dot group by, group. Okay, I can type group for some reason. So group by, and then I'm going to group by the payment method that was used. So payment method, and I'm going to do dot count, and then I'm going to get the following column. So I'm going to get the following. I'm going to get the gender column. So gender, and I'm also going to go ahead and get the churn. Okay, so once I have that, I can just simply do a payment method just like that and simply run it. So once I run that, I get this value right here. So I want to visualize to see which payment method was commonly used. So you can either use the gender or the churn, because basically they're the same values. Okay, so I'm going to go ahead and use the let's just use the churn. So I'm going to do a plt.figure, and I'm going to specify the fig size to be equals to a tuple of 7 by 5. Okay, just like we have done. And then I'm going to do a plt.py. Okay, I'm going to say x, and x is going to be equals to the churn, right? So the churn, which is this column right here. And then I'm going to specify the data, and the data is going to be equals to the payment method data frame. And then I'm going to use auto PCDs, and this is going to be equals to the string, and it's going to be percentage 1.2 f, and then percentage. And then I'm going to go ahead and specify the label, and the labels is going to be equals to the index of this. So I'm going to say payment method dot index, which is this value right here, which is the different payment methods. Okay, so once I have that, I can just go ahead and pass in a title and then visualize. So I'm going to say plt.title, and the title is going to be payment method on churn rate comparison, just like that. And I can do plt.show, just like that, and visualize this. So once I visualize this, I have the graph right here. So you can see the different payment methods that were used, and I think the most commonly used payment method was electronic check, and then we have followed by mail check, and then followed by this one right here, which is bank transfer, and the last one is credit card. Okay, so yeah, those are the payment method that I use. That's a bit strange. I thought like the credit card or something or bank transfer will be used more, but or credit. Yeah, this one sounds okay, because nowadays you're using a lot of electronic payment systems. Yeah, so basically now that we have this, I want to go ahead and draw some other graph. So I'm just going to draw I'm going to draw a histogram to show the different total charges and the monthly charges. Okay, and against the churn, like how ample they have churn based on how much they are paying. So let's go ahead and actually do this. I'm going to go ahead and create a column here. So I'm going to create I'm just going to make this a markdown and call it histograms. I'm going to go down here, and I'm going to say interests underscore feature underscore calls. Interest feature columns is going to be the following. So the first one is going to be total charges, and then the second one is going to be monthly charges, just like that. So once we have the total charges and the monthly charges, I'm going to go ahead and run the cell. So I'm going to do for feature underscore call in interested, right? So in interested feature columns, I'm going to do a positive, which is the ones who have churn. So I'm going to say positive underscore data, and this is going to be df, and I'm going to go ahead and get the df of the churn, where it is a churn equals to a yes. Yeah, yes. Okay, and I'm going to go ahead and get the feature column that you're interested in. So it will be feature column, just like that, and I'm going to get the negative underscore data, and this is going to be equals to df, and I'm going to select the part whereby the df the churn is equals to no. So churn whereby the churn is equals to no, just like that. And I'm going to go ahead and select the feature column, just like that. So once I have selected those, I'm going to go ahead and create a figure. So plt.figure. I'm going to use for loop to draw these two graphs, because if you have more data that you want to do, you can just add it here and then run this for loop. It will draw all of it for you instead of doing it manually. So figure size, and I'm going to do figure size going to be 7 by let's do 12 by 7. So 12 by 7. Just to make the graph a bit bigger, and I'm going to say sns, right, cbon.histplot, and I'm going to simply say positive underscore data, and then I'm going to say beans. I'm going to say beans to be around 30. You can use alpha value. So the alpha just controls the transparency, like the alpha channel of an image controls the transparency. The alpha channels here just control make the label, the coloring to be a bit transparent. So label equals to I'm going to give it a label of yes, I'm going to make it a capital EY, and then I'm going to go ahead and say color, and the color is going to be green. So this is a churn, so let me just make this to be quotes green, just like that. And I'm going to use KDE, and KDE is going to be equals to true. So once I have that, I can simply copy this and paste it one more time on a new line. So once I have this here, this is going to be negative data, so negative, and everything remains the same, and this is going to be no, and this is going to be red, just like that. Yeah, that's basically it. And once I have this, I'm going to give it a legend. So I'm going to say plt.legend for that legend to legend to show up. So legend is going to be going to be the location, and you're going to give it on the upper right. So I'm going to say upper right, just like that. Yeah, I think upper right is fine, or you can use yeah, upper right is fine, and then you can give it a title. So plt.title, and the title is going to be you can use an f string if you want. So I'm going to say f string, and I'm going to use positive and negative histogram 4, and then histogram 4, and then you're going to now pass in something. So I'm going to close off that, and then we're going to pass in just the feature column that we are referring to. So once I have this, I can do plt.show, just like that, and simply run this dataset. Okay, run the code, and I have an error here called churn. So let me see, this is going to be capital C. Okay, so run that, and now we have the graph right here. We have these two graphs being plotted right here. So yeah, this is basically the graph, and we can see that the most people the ones which don't which are churning are actually the green, and the ones which are not churning, that means they're staying, actually the red one. Actually, we can reverse these colors. We can make this one to be red instead, and this one to be green, just like that, and simply run it. So the red ones are the ones who are leaving, and then the green the no ones, or the green ones, are the ones which are staying. And you can see that the as the charges will go lower, so those guys who are paying lower are actually having a higher churn rate, but the who are having total charges, the ones who are having lower charges are actually churning, but the ones who are having higher charges are actually staying, maybe because they're using the service more and more and depend on it heavily, so they aren't churning much. But guys who are having lower total charges are actually churning more. And maybe, yeah, because they haven't invested much, kind of like makes sense. And also, let's look at the monthly charges. And for the monthly charges, the guys who are actually paying lower for monthly charges actually have a higher stay, while the ones who are paying it's actually very I can't say much about this, because it actually looks kind of like normal to me, because the monthly charges, they increase, people churn a bit, and then later it decreases and stuff like that. So I think it's okay. If you guys see any difference in this chart, let me know in the comment section below what you think about this graph. Okay, so once we have done the expert data analysis, let's go ahead and actually try to label and code it, because if you look at our data frame currently, so I'm just going to go down here and simply do a df.head, just like that, and simply run it. You can see we have a lot of categorical value that is not encoded. So let's go ahead and actually encode those values. Okay, so I'm going to go ahead and actually encode them. So I'm going to simply go ahead and make this a markdown, and let's say categorical encoding, just like that. So I'm going to do for column in df, right? So column in df, I'm going to print f, and then I'm going to say the following. So this is going to be a string, and I'm going to say this. I'm going to go ahead and say column, the column that you're interested in, and then I'm going to say like df, and then I'm going to get that specific column, which is going to be column, and then I'm going to simply do dot unique. So this is going to be needs to be like a code itself, so I'm going to put inside of curly braces dot unique, just like this, and then simply call it. So let's run this cell and let's see what we get. So we get the unique value of all the columns. So for female, we have only male and female. Citizen, we have only 1, and senior citizen, we have only 1 and 0, like if a person is senior citizen or is not. Partner, the person has a partner or not, and dependents, no, yes or no. and then general, we have all this, and then font service, either yes or no. So I want to select the columns that are having exactly 2 categories, and you're going to use label encoding for that. The rest you can use one hot encoding, because if it's exactly 2 values, label encoding will not give the model any hierarchical assumption. But if you use label encoding for more than 3, more than 2, it can give it like a hierarchical assumption, which is not what you're trying to implement. So I'm just going to go ahead and say I'm going to say from sklearn sklearn.preprocessing. From sklearn.preprocessing, I'm going to go ahead and import the phone. So I'm going to import label encoder, just like this, and I'm going to go ahead and run that. So once I have label encoder import, I'm going to say label underscore encoder, and label encoder is going to be label encoder, and just simply create an instance of it. So I'm going to say for categorical column, for cat underscore call in df.select, I'm going to select underscore d types, and I'm going to select the d types of object types. So I'm going to simply say object. Instead, I'm going to select the types of object, and I'm going to get their individual columns, just like that. I'm going to say if the length of the df, right, of categorical column dot unique, we're going to check the unique values, right? We're going to check the unique values, and we're going to check if the unique value is equals to 2. In that case, right, we can use one hot encoding. So I'm going to say df, then I'm going to say cat column, right, the column that you're working with, equals to label encoder dot fit underscore transform, and I'm going to fit transform the df and then the categorical column. So I'm going to say cat column, just like that. And in case it's not 2, right, it's not 2 means it's 3 or more. So I'm going to say else, you're going to say df equals to df pd, right, pd dot get underscore dummies. That's another way we can create categorical values. And I'm going to say the data is going to be equals to df, and then you're going to go ahead and say the column, and the column is going to be equals to the following. So I'm going to say cat underscore call, just like that. So this should now be able to label encode our data. So if I do df.head, and let's be able to see that. Okay, so we visualize it now. You see this one is just 2 columns, so it's label encoded. But for now, let's look at one which was having more than 1, which is multiple lines, right? We have 1, 2, and 3. So multiple columns now should be one hot encoded. So multiple columns, you can actually see it here. Yeah, it's just hidden here. So let's actually pick another one, which is okay, payment method. It should be, we have 1, 2, 3, and 4, right? Yeah, so that one should be one hot encoded, the payment method. You can see it's one hot encoded here. So great. So we can actually drop one of this just to avoid any this error is called I forgot even the name of this error. If I remember it, I'll just tell you, but currently I forgot it. Is called multi-collinearity or something like that. So we can actually drop one of these columns if you want, but I'm just going to leave it in there for now because it's not going to have much effect. But if you want, you can drop one of this payment method, but I'm just going to leave it in there. So once we have that, I'm just going to do a df.columns just to see which columns that we have. So df.columns, and then run that. So we have all these columns right here. Okay, so I want to split the data into training and testing sets. So we're going to use the churn for x, and then the other ones are going to be used for so we're going to be using the churn for y, and the other ones are going to be for x. So I'm going to say create a markdown here, and I'm going to call this split data, just like that. So do that into training and testing sets, just like that. Okay, so I'm going to simply do it from sklearn.model underscore selection import train underscore test split, just like that. And once I have that input, I'm going to say x is going to be equals to df, and I'm going to simply go ahead and drop the churn and keep everything else. Okay, so I'm going to say drop, and I'm going to specify the churn here. Means you're going to use everything for x other than the churn. I'm going to say axis is going to be column, so it's going to be a string of columns. Then I'm going to do y is going to be df, and then it's going to be just the churn. Okay, so it's going to be a string, so churn. Okay, run that. So I can do x dot head and then run that. So you have everything here as except the churn, right? And you can do y dot head, so I can do y, and the y is this value right here. So once we have that, I'm simply going to go ahead and now split the data into training and testing set using the model train test split that we imported. So I'm going to say x underscore train x underscore test comma y underscore train comma y underscore test is going to be equals to train underscore test underscore split, and I'm going to simply going to pass in x comma y comma train. I'm going to specify the train size, so train underscore size, and the train size I'm going to use 0.8. I'm going to use 80% for training, and then I'm going to specify the random state for repeatability, so random underscore state, and random state I'm just going to use 800, or it's any number you can use. So once I have that, I'm going to now have x underscore train. I can check the shape, so shape, so we're going to use 5625 rows for training, and you can do x underscore test that shape. See, we're going to be using 1407 for testing. So great. Once I have that, I'm simply going to go ahead and build our model. So now we reached the place of building our machine learning model. You're going to be using a dense neural network for this. So I'm going to say build model here, and to build the model, I'm just going to go ahead and import a couple of things. I'm going to say from Tensorflow, Tensor. And it's always good practice to keep these imports at the very first cell, but I'm just going to keep it here for simplicity. So from Tensorflow, I'm going to go at it from Tensorflow.Keras, right? From Tensorflow.Keras, I'm going to go ahead and import sequential, just like that. I'm going to go ahead and import sequential. I'm also going to go ahead and say from Tensorflow.Keras, I'm going to go ahead and import a dense neural network, a dense layer, and I'm going to import also OS. The reason I'm importing OS is because I'm using TensorFlow GPU version, so that's why I'm using that. So from TensorFlow, this is TensorFlow.Keras.layers. Okay, layers. I'm going to import the dense layer. Okay, good. So now that we have that, I'm going to say os.environment. I'm going to go ahead and specify the following. So I'm going to say tf, so TensorFlow, and then xla, and then underscore flags, so flags, and then I'm going to say equals to, and then I'm just going to be quotes. So I'm going to say hyphen tf underscore axl sorry, it's going to be xla underscore enabled, and then I'm going to say xla and then underscore devices, because I want to use my graphics card. So I'm just going to go ahead and run that. So we got an error. Let me just look at this from my other screen. So it's going to be TensorFlow. This is going to be an underscore instead and not a hyphen. So it's going to be underscore flags equals to TensorFlow as well as enable. So this is going to be enable XL devices. So run that, and I still got an error here. So let me just carefully go through this. Yeah, I spotted the error here, and I used double equal instead of a single equal, so that was the cause of that error. So once I have this, I'm going to go ahead and still build a model. We're going to use a sequential model. So I'm going to say sequential, and then I'm going to create a sequential model here. So once I have that created, instead of this model, I'm going to go ahead and add in the following layer. So I'm going to add a dense layer, and a dense layer is going to be having how many neurons we want. So I'm going to say units, and unit is going to be, I'm going to have 40 units, because if you look at data set, first shape of it is 40, so I'm going to use 40 for the input, and then I'm going to say input underscore shape is going to be the following. So I'm going to have input shape, and input shape is going to be 40, just like this. This is just a single tuple, so we have to keep the comma here, so make sure that you do that. Sometimes it can be easy to skip that. And I'm going to specify the activation, and the activation is going to be a relu. So it's going to be a string, and I'm going to say relu, rectilinear unit. I'm going to go ahead and specify another dense. So I'm going to say dense, and I'm going to say units, and units is going to be going to have 15 neurons in here, and I'm going to go ahead and specify the activation. activation is going to also be really low. So you don't need to provide in here the input shape anymore, because the dense network will automatically figure the input shape that is going to come into this layer. Okay, so once we have that, I'm going to go ahead and create another dense layer, and this dense layer is going to have units, and the units is going to be 1 unit. The reason why it's going to be 1 unit, because the very last unit layer, right, we want either an output of 0, like the customer is not going to churn, or an output of 1, the customer is going to be churned. So we just want 1 neuron at the end, and it's going to have an activation of activation of sigmoid. So I'm going to say string and sigmoid, just like that. Yeah, that's basically what we need. And I forgot, this is supposed to be inside of a list, so this is going to be closing the list here. Yeah, so that's basically what we need to do. So once we have that, I can simply run that right there. So just ignore those warnings for now. Now let's go ahead and actually do our model.compile. And as to compile the model, I'm going to go ahead and pass in the following. So I need to pass in the optimizer to use, and I'm going to say the optimizer, and the optimizer is going to be Adam optimizer, and I'm going to go ahead and specify the loss, and the loss is going to be the following. So the loss is going to be a binary underscore cross entropy. So binary cross entropy. Okay, so binary cross entropy, we are using binary cross entropy because we just have a binary value, right? Either the prediction is a binary value, either a yes or a no. So that's why we're using a binary cross entropy. And we say matrix, and the matrix is going to be equals to going to be a list, and you're going to pass in accuracy inside there. So once I have that, I can simply go ahead and run that cell. So I get an error here, say model. Okay, this is not mod, it's going to be model, and run that. So once our model is compiled, now we can go ahead and simply fit the model, or simply train that model. So fit, we're going to pass in x underscore train, x train, and we're going to say y underscore train, and we're going to say validation underscore data, and validation data is going to be equals to the following. So the validation that is going to be x underscore test and y underscore test. We're going to use that for validation data. And now we specify the number of epochs in which we want to train this. I'm going to say epochs, and number of epochs, I'm going to use an epoch of 80 epochs. So once I have this, I can simply run it, and we can begin to train our model. So this will take some time, so let's give it some time as it trains. But what you can notice is that the loss gradually reduces as the model trains further and further. So we're going to go until 80 epochs, and once that's done, we should be able to continue with the tutorial. And once we find the number of epochs, don't specify too much epochs or too little, because there's something also known as overfitting. If you print the model so much, it can overfit. So there's also that category. So be careful. Sometimes we need to like use hyperparameter tuning to choose the best value to use for the epochs. But for now, we're just going to leave it to be 80. And our model is trained, and you can see we have a loss of 0.3, and we have accuracy of 70 around 79%, and validation accuracy of about 80% validation accuracy. So great. So once we have this, this is a validation accuracy right here, and this is a training accuracy. So once we have that, then I'm going to go ahead and try to evaluate the model and see how the model performs. So I'm going to go here and simply say model evaluation, and for model evaluation, I'm going to model.evaluate, and I'm going to say x underscore test and y underscore test, just like that, and simply try to evaluate the model. So we can see we have this is the accuracy, and this is the loss. Okay, so we have an accuracy of about 80% accuracy, so the model is quite good. So once we have this, I'm also going to print a classification report. So I'm going to say from sklearn dot metrics import classification report. I'm also going to go ahead and import confusion metrics, just like that. So once I have those two imports done, I'm going to go ahead and print the classification report. So I'm going to pass in the y underscore y underscore test, and also we need to pass in the prediction. So we need to go ahead and get the prediction and be able to use predictions right here. So above this, I'll actually skip one step. I'm going to create a cell above this, and I'm going to call this use for prediction. So I'm going to say make predictions right here. So in here, I'm going to go ahead and simply make predictions. I'm going to say y underscore predict predictions, and y prediction is going to be model.predict. we need to pass in the x underscore test because we're trying to predict the x text. Run that, and I'm going to create a cell above here, below it, and I'm going to simply do y underscore predictions, and then just get the very first one, and we have this right here. So we have this value which is between the number between 1 and 0. So we actually go ahead and actually make the scale process data. So if it's less than around 0.5, or if it's greater than 0.5, or if it's less than 0.5, we can say that it is a prediction of 0. If it's more than 0 or equals to 0.5, we can say that it's a prediction of 1. Okay, so I'm going to say y underscore prediction. Y prediction is going to be equals to a list right here. I'm going to say 1. I'm going to say for prediction in y underscore predictions, right? For each of those predictions, we're going to return 1 if that prediction is greater than 5. Else we return 0. So if it's greater than 5, you're going to return 1, also going to return 0. So run that, and now if I go up here and then create a cell below here, I can do y underscore predictions, and then simply get access to this, and now it should be 0 because this value originally was less than sorry, this can be 0.5 and not 5, so 0.5. yeah, so run that, and you can see now this value is less than 0.5, so it returned to us 0. So yeah, this is a list comprehension. So once I have this, I'm now going to go ahead and pass in y underscore predictions right here and simply run this. So great, we have this value right here. Just ignore this warning for now. We have this value right here. You can see the recall, the precision, and all that, those values right here. Yeah, so if you want to understand what recall, precision, and all these values mean, I have a simple tutorial that explains all these values and their meaning and stuff like that. So I'm going to leave a link in the description so you guys can access this. So I'm going to say confusion matrix, and it's going to be confusion underscore matrix. Then I'm going to go ahead and pass in the y underscore matrix. I'm going to pass in y underscore test, and then y underscore predictions. And once I have that confusion matrix, it's going to look something like this. So if I run it, it looks like this. So now let's try to visualize it. So I'm going to use Seaborn and math.lib. So I'm going to say plt.figure, and I'm going to say fig size, and the fig size is going to be equal to the following. So I'm going to say 12 by 7, and then simply plt.title. To give it a title, we can say confusion matrix, just like that. And then we can also specify the font, this font size, and the font size is going to be, you can use font 18. And then I'm going to plt.heatmap. So heatmap, and the heatmap I'm going to say is going to be the confusion matrix, and then are not equals to true to show those numbers. So are not equals to true to reveal the numbers inside of the confusion matrix. So I'm going to say plt.x label, and x label is going to be predictions, and y label is going to be the truth. So y label is going to be the truth, and I'm going to do a plt.show at the very last button. So we have an area. It says a heat model hits. So it's going to be SNS rather, SNS, and then yeah. So once we have that, we have the confusion matrix right here. So I actually think we made an error right here. The graph doesn't look okay. So when it was 0 times, when the truth was 0, it predicted 0. When the truth was 1, it predicted 0 this amount of times. There is something wrong with confusion matrix. Okay, so let's look. I think the error is probably here. So return 1 if prediction is greater than 0.5. Let's see if prediction is greater than 0.5, else. Oh, okay. So because we ran it before, I have to start again running it from up here, and then I think that should now solve it. Yeah, now that should solve it. The reason why because is that previously I specified it to be 5, so and I saved it in my prediction. So when you run when we change this to 0.5 and run this cell again, the change has already been done, so I have to start running it from up here. Okay, so once we have that, you can see all those values right there, and you can see the values right there. So when the truth was 1, our model predicted 1 this amount of times, and when the truth was 0, our model predicted 0 this amount of times, and the truth was 0, our model predicted 1 64 times. When the truth was 1, our model predicted 0 this amount of time. So looking at this data, our model is actually weak in predicting ones and is actually good in predicting 0. So we can do a hyperparameter tuning or add more data to it so the model can learn better. So but for this tutorial, I'm just going to go ahead and simply end it here. So you guys, if you have any questions, let me know in the comment section below. Also drop a comment in the comment section below to help the YouTube algorithm suggest this video to other people. Like the video, share the content with anyone who you think might find it helpful, and let me know if you have any questions that I can help you with. So thanks for watching, and see you in the next one. Yeah, that's basically it. And if you're not subscribed to the YouTube channel, please kindly consider subscribing, liking this video, and sharing this content with anyone who you think might find it helpful. Thanks for watching, and see you in the next one. Keep safe.